Okay, class, picking up where we left off. We left off on problem C here. Now remember, we took this value here. We had 81 times 10 to the negative 8th power. And what happened was, remember, we could only have one digit in front of the decimal. So remember, whenever you have a whole number, the decimal is always at the end of the whole number. So we had to move this decimal one place to the left, and that gave us 8.1. Now, whenever we move a decimal to the left, no matter how many spaces it is, we must add that value to the exponent of this 10. So since we move one place, we will add 1 to the negative 8. Had we moved two places, we would have added 2 to the negative 8. So now, our final answer would be 8.1 times 10 to the negative 7 power. And that will be our final answer for C. Now we scroll down here. We scroll down here to objective 6, example 9. Now it says solve applied problems using scientific notation. It says example 9. If there are approximately 3.2 times 10 to the 7 power seconds in a year, approximately how many years is 1.35 trillion seconds? Now I took the liberty of solving this problem, but first of all I need to show you where we got this 10 to the 12th power from. We need to scroll up here, and I believe it is page 114 that we need to go back to. So I'll scroll back up here to page 114. Take a little second here, but we're almost there. Okay, this is page 114. Now we scroll up to this chart that's coming up. Now this chart here, let me stop here. Okay, they give us the names of large numbers. So what we do here, we look on this chart on page 114 and look for the power of 10 that represents trillion. Trillion is 10 to the 12th power. Now, this is where, let me scroll back down here. We're on page 116. I'll keep jumping back and forth here. Let me get this okay. Okay, so now we scroll back here. Example 9. Now again, trillion is represented by 10 to the 12th power. So we have 1.35 trillion seconds. Now, reading this question one more time. If there are approximately 3.2 times 10 to the 7 power seconds in a year, approximately how many years is 1.35 trillion seconds? So we will write this in scientific notation. It'll be 1.35 times 10 to the 12th power. So we know 1.35 times 10 to the 12th will give us the 1.35 trillion we were talking about. Okay, now, in our denominator, we had 3.2 times 10 to the 7th power. So now, we would divide. We would separate this like I showed you earlier. We'd take 1.35 divided by 3.2, and when you type it in your calculator, it'll give you 0.42188, and then that's times. Now we have the same base here with the 10, so we write the base and we subtract the exponents. The exponent of the numerator minus the exponent of the denominator. 12 minus 7 is 5. So we have 0.42188 times 10 to the 5th power, and when we multiply it out, it will give us 42,188 years. And that is our final answer for that problem. Now, we scroll down here to the last problem of this exercise, example 10. I took the liberty of doing example 10 as well. Now, it says as of June the 12th, the national debt was 15.8 trillion. Now, remember from the previous problem, trillion is represented by 10 to the 12th power. Now, at that time, the U.S. population was approximately 313.8 million. Now, millions, you can go back to page 114, but millions is represented by 10 to the 6th power. If the national debt was evenly distributed among every individual in the United States, how much would each citizen have to pay? So we'll take the 15.8 times 10 to the 12, because that will represent your 15.8 trillion. And then with the 313.8 million, we would take that and multiply it by 10 to the 6th power. So it'd be 15.8 times 10 to the 12. That would be 15.8 trillion. And 313.8 times 10 to the 6th will be your 313.8 million. Now, we set this up like we did the last problem. We'll take the 15.8 divided by 313.8. And in your calculator, that will give you 0.05035. Okay, times. We look here at these common bases here. We'll bring the 10 over, and we will subtract the exponent of the numerator by the exponent of the denominator. So it'd be 10 to the 12 minus 6, and 12 minus 6 is 6. So now we add 0.05035 and multiply by 10 to the 6, and that will give us $50,350 per person, because we will have to move this decimal 6 places. And that is our final answer.